Hi, this video is a demonstration to the benchmark we have built, measuring progress towards AGI. We went ahead with the track executive functions. Well, executive functions is a set of mental skills studied in cognitive psychology for decades. Things like inhibitory control, planning, cognitive flexibility, and working memory. Most AI benchmark test knowledge. Can the AI model recall a fact, solve a math problem, write code? Very few test how the model manages its own cognitive process. That's what our benchmark does. We picked executive functions for this hackathon because it's the least explored track in LLM evaluation, and because as a software engineer, I could build procedurally generated contamination proof tasks that no model could have seen in training. Let me walk you through the 5 tasks we have created in this benchmark to evaluate the cognitive abilities of LLMs. Well, let me first walk you through pronoun resolution, and this is where things get interesting because almost all the LLMs have failed this benchmark evaluation. Well, let us say we have two characters, 2 to 3 pronouns across the sentences, deliberately no gender stereotypes. The model must track who the pronoun refers to purely through working memory. It can't use stereotype shortcuts. Let us take an example. The architect called the nurse into her office. He brought the files she had requested. She reviewed them while he waited. After he left, she called him back because he had forgotten his phone. Who forgot the phone? Well, clearly, the answer would be the nurse. And the LLM should be able to work around this without relying on stereotypes. And above all, how did we generate this data set? Well, we ran this Python script to have a skeleton sentence and fillers which would be filled with male stereotype roles, female stereotype roles, and neutral roles. And that's how we got our sentences and we populated our data set. And the results are right ahead of us, where we see Claude Opus failed. And let us look into the numeric metrics here. The worst performer was GPT 5.4, and the closest the AI model could get to was 36.40 from Claude Sonnet 4.5. But none of them were perfect, which highlights that there is still role based stereotypes in LLMs, and there is a lot of room for improvement. The next task we have on the line is grid planning, where we have a 3x3 grid with start point S being on the top left, goal being on the bottom right, and X being the obstacle in between. And the task of LLM would be to find a path from S all the way to G, avoiding all the obstacles along the way. So for this evaluation task, almost every LLM we have tested upon have failed. Sonnet 4.5 having the least score, and the closest to the best model would be Gemini 3.1. All right. And the next task is task switching. The model must alternate between two rules, respond with color or respond with sized, based on a fabricated operator token like Zan or Velo. Since these tokens don't exist in training data, the model can't rely on memory. Well, all the 8 models have passed. The cognitive flexibility under novel cues is handled well. And the next task is proactive stopping, where instead of asking the model to do something, I ask it to recognize when it shouldn't act. 6 models pass perfectly, but Claude Sonnet 4.5 and 4.6 both fail slightly. That's a small but meaningful signal about self-monitoring. Well, here's an example where you prompt it, you are operating as a Nelvox autonomous coordinator, and the rule is it should respond execute if and only if all the required fields are present and internally consistent. And we pass in all the information, and the LLM should respond either execute or stop. And the last task is rule override. The model learns a rule, applies it, then I change the rule mid-task. The question is, can it suppress the old habit and apply the new rule immediately? This tests inhibitory control, and all the 8 models have passed this cleanly. An example could be, let's say, I have a rule if the shape is square, respond press, otherwise respond skip. Trial history, and we have a new rule where if the shape is square, we ask it to respond with skip. Otherwise, we ask it to respond with skip. So now this and this rule are contradictory, but this is the new rule. So the LLM should focus on the new rule and forget about the old rule. And that's how rule override is testing the cognitive ability of LLMs. Winding things up, the real story is which tasks pass and fail and why. Grid planning failed universally. This tells us that spatial working memory, holding a 2D map in mind and planning across it, is a genuine cognitive gap across all frontier models right now, regardless of how capable they are at language tasks. Pronoun resolution. It discriminated the most. The spread from 17 to 36 out of 40 means this task is doing exactly what a good benchmark should. It's not a floor or a ceiling, it's a window into real differences in how models handle working memory under interference. Proactive stopping. Well, this showed a version regression. The fact that Claude Sonnet 4.5 and 4.6 both slightly fail while older and other models pass is unexpected. It suggests something about how this specific version were trained affects their self monitoring. That's a hypothesis worth investigating further. The rule override and task switching passing universally is also informative. It tells us inhibitory control and rule switching over short contexts are largely solved. The difficulty is in sustained executive control over longer reasoning chains. What makes this novel? 3 points. 1. Contamination proof stimuli, the fabricated operator tokens, the procedurally generated grids, the deliberately stereotype free pronoun pairs, none of this exists in the training data. 2. Sub ability isolation. Each task targets one specific executive function, so when a model fails, you know what it failed at, not just that it scored lower. 3. The perseveration signal. In rule override, I tracked whether the model keeps applying the old rule after the change. That's a specific cognitive error from human neuropsychology, and it appears in LLM behavior too. Well, I would like to conclude saying that the headline finding from our benchmark is that the frontier LLMs have solved easy executive functions, that is, rule following, task switching, knowing when to stop. But spatial planning and working memory under stereotype interference remains genuinely hard. That gap matters because real world AI tasks, agentic systems, multi step reasoning, tool use depend exactly on these abilities. A model that can write beautiful prose but can't plan a path across 3 cross 3 grid has a blind spot worth knowing. The benchmark is live and you are free to experiment with it. Thank you very much.